And there's, I mean, it's good to, and as far as what's the difference between a job and a process? I wanted to kind of touch stuff like that a little bit. Just because as we start debugging these things, things will happen, and at least knowing what's going on, I think is going to be a very useful feature. So I was thinking of walking through that stuff, and let's see if we can get the projector to see, so you can see what I'm typing, and then I'll try to put the notes in the center. Will that come up? Eeny, meeny, miny. Ta-da! So if could people more or less see that? If we do the lights, let's see. We do that. Does that make it a little better? So step one, let's talk part one, virtual box. So why do I want to do virtual machines? Let me just talk about that. I don't know how much we talked about it on Wednesday. People have used virtual machines on their laptops. So 3 steps back, Linux tends to be the operating system of choice because ROS works best under it. It's kind of the traditional, most robotics uses it, and so I want to use Linux. Ideally, I'd love to use it native. Okay, another question: who runs native Linux on their laptop? Please do that. That's awesome. I'd run everything, and I actually thought about forcing everyone to install native Linux on their laptop. The problem with that is that if you've never done it before, if you've done it, it's easy, right? It's fine. You can dual boot, not a big deal. If you've never done it before, and you don't quite know what you're doing when you do it, there is a 1 in, I don't know, 20 chance that you might accidentally erase everything on your laptop. So, I decided that would be a tough thing to enforce. So if you want to, and kind of as we go through this, and you eventually realize that the virtual machine is annoying because it's slow, we can definitely do things natively. It'll be faster and more reliable. The way that I want to get out of that is that we actually want to buy, I think I mentioned, small Intel NUCs, which will run natively Linux to control your robot. So the UI and the debugging you can do on your laptop. And if it's virtual and if it hiccups, fine. But then the real machine can run native Linux to run the robot. If you've got native Linux on your laptop, as mentioned, all the better. If not, we can put on a virtual machine. There's a bunch of virtual machines you can use. VirtualBox, I believe, is the one of choice around here because guess what? It's free. That's always a good feature. And so what I would do is encourage people to install it. And so if you've never done that before, look at VirtualBox. Guess what? They've got a big download button. And there's 2 things to point out. One is that depending on what your platform is, I don't know if you guys can read it, Windows OS X, Linux, Solaris. I don't think anyone's going to be running Solaris, are they? It seems kind of historical. The other one, there's an expansion pack. You want to get that because that's what supports the USB drivers. And if you want to plug in a camera or do anything like that, it's a useful thing to have. So if you don't mind putting that one in, so that's the expansion pack. Once you have it, I'm obviously going to skip that step because I'm too lazy to try to do that here. It looks kind of like you had that, like that. Can I make this bigger? It seems awfully small, isn't it? How would I make the screen resolution bigger? I assume is it too small to really see? Yeah, it's too small, right? Where is my
displays?
Displays. Not there.
Oh.
Displays. Triggering
Arrangement?
everything.
That's scale.
Where is scale? There's scale.
You want a lower resolution.
That did not.
Try 720.
And nothing. Okay.
Yeah, it's bigger.
That's better. Let's do that. VirtualBox will have something like that. The normal thing to do is say new, and you can give it your favorite name, my VM. You can obviously stick it to Linux, and you can stick it to Ubuntu. So we're going to do Ubuntu. The reason we do Ubuntu is because that's what ROS is built off of, and it'll just make life easier if we stick with it. If you go through this, a couple of things that I want to point out. One is pick your memory size. They default to saying 4 gigs. They default to saying 1 gig, which I assume at this day and age is kind of small. So I go usually 16 or whatever, like half your. I tend to put it like at half, whatever you have got available. It's a good thing to do. Create a virtual disk. Again, it's going to be about 10 gigabytes for the virtual disk. Probably the whole thing is going to be about 20 gigs. So I'm hoping that you've got that much file space. If not, let me know. We'll try to figure out what we can do, but it's going to be roughly in that order. If you do all of that, it'll eventually ask you, yes, make the disk, et cetera, et cetera. It'll create your new VM. When you try to run it, actually, quote, quote, turn it on, it'll ask you for an ISO. And so if you want to, you can run off a Ubuntu ISO and download that, right, which is Ubuntu 18.04. What I'm going to try to do, I have not done this before, but is actually skip all of that, and upload a copy of what I have to, has anyone ever done that to Piazza? Can Piazza take an 8 gigabyte file? Is there a way to distribute an 8 gigabyte file?
Fox might do it.
So I'm going to have to take a look at that. So the long way is you download the Ubuntu, you install it, and then you run Ubuntu, and then you install ROS, and you do all of that, and that thing will take like an hour to download everything and install. The other option is you can basically say import and give it a virtualization format of file, which I copied. Well, I don't need to load it now right now. So I can save the default configuration that I have. Go away. How do I get you to go away? Cool. So that you don't have to reinstall it. So I can put up an OVA file. And so let me take a look whether I can put, it's 8 gigabytes long, right? Because it's the entire operating system with all configurations and everything built into it. Let me see if I can put that on Piazza, which probably will break. If not, let me figure out if I can put it on Boxer where I can put it. Because that way you guys don't have to go through the full install. If you want to go through the install, please do. It's a fun thing to do, but it'll just take an hour and it'll be annoying. So let's see if I can avoid that. Does that sound okay? If I figure that out, I will, and I am going to, well, first of all, close you, power off, sorry. Didn't want to clean up after myself. Power off, and remove. How do I get rid of this? Remove. That was the one I never removed the default file. So assuming we've done all that, and there are basically Ubuntu and app, and if you do want to install it, basically just look up ROS install, and they've got a man page, a help page that will tell you how to install it if you want to do it yourself. Otherwise, I will give you the OVA, and you can just run it from here, which means when you turn it on, voila, it boots itself into Linux, and when all the messages go away, now that I've got higher resolution, ooh, that's big. I should have a blank screen. Wow, that's big. Let me do something here. Oh, sorry, I got confused. We were talking about settings. So the system, we said, should have probably about 16 or a few half a gigabytes of memory, right? The other comment is you can set the number of processors. Again, I tended to set the half of the available. That's usually they default to only giving you one CPU, but I usually put out at 3, 4 kind of CPUs based on what the number of cores you have. You might as well make them balanced. And the last one is the display. If you can, enable the acceleration so that it'll actually render faster. But what I was going to do is just set this to be 100%, so that when I run it, get a slightly more useful size like that. You can set the display, memory, and size. Those are the ones that I generally set. Does it seem reasonable how to get there? The OVA that I have has a username. I just put in robot, because that was the best I could think of. And the password, guess what, 134. I couldn't think of anything better. Highly secure, but it's just a virtual machine, right? So no one's going to break into it when it's off. So does it seem reasonable how to get there? And assuming we can install a virtual machine, do that? Everyone bored yet? Any thoughts or questions? So I wanted to spend 15 minutes talking about Linux. And the reason I wanted to talk about Linux was, well, commands, which I assume at this point are command line, then fairly common to people, but let's just go through them quickly. What I wanted to talk about, let's see, was processes versus jobs. Because guess what? Things are going to crash and you want to kill them. And you want to know where they are and what they are and how to do that. So that's usually a useful thing to know. And I wanted to talk briefly about environment variables. Because that is how ROS sets itself up and talks to each other. And so you need to set those up and or make sure that they're set up correctly. And I don't know if these are completely obvious, but usually those are the kinds of things that people kind of know, they happen, and sometimes they work, and then if they're not set right, everything goes a little weird, so I wanted to talk about it. Does everyone, if I say shell, who's willing to admit that they don't know what I mean? Cool, thank you. So, part one. If you open a terminal, assuming that I haven't gone to sleep here, I have gone to sleep. If I open a terminal, it creates this window. What it actually is just for clarity, is a window, and then inside of that window it runs what it calls a shell, which is actually the command line interpreter. And that is just for the fun of it. You don't actually really need to know that distinction. But it turns out I could actually, there are a bunch of different shells. So if I do this, I can start up a new shell, which is just called shell, right? And then now I'm inside of a shell inside of the shell. And I can exit from it again and be back to the previous one. Don't really do that. It's kind of a stupid thing to do. The reason I mention it mostly is because the shell of choice, so SH is the very basic shell. That's the oldest one that's been around. Then there was C shell, then there was T shell, then they had Z shell. You guys have heard of bash? I don't know born again, so bash is born again shell. Linux folks like coming up with weird acronyms and names. If you haven't heard it, that is basically going to be, bash is the command line that we run. The reason I point that out is because if I look at my files, then if you look at your home directory, you will actually see a history file, a bash history file, which is what it keeps naturally. And in particular, you'll see a bash RC file. And that's probably one that you might at some point want to edit. What that is basically whenever you start a new shell, that gets sourced to figure out how to set itself up. So just for the fun of it, if I open this with a text editor, there's a whole bunch of stuff in here. So guess what I'm going to do? At the very end of this, I'm going to say echo, yes, old-fashioned hello world. Okay. So if I save that, and then guess what? I start a new terminal. Whoops, what did I do? If I start a new terminal, or new tab, first thing it says is hello world. So that means the home directory / .bashrc is the configuration Does anyone know what RC stands for? They always mean RC, and that is always the configuration, but I don't know why RC.
How's the reference configuration?
Reference configuration? That might be what it is. But it's a typical usage. So it's the bash RC. There's different RC files. And sneak preview, if you look at the RC file, the very last thing that's in here is this source melodic, right, which is how it sets up ROS. And we can play with that and potentially change that. And so that's why I want to mention this. I'm going to kill that part because I don't really want it. So that's the shell. And so the configuration away is in bash RC. I'm guessing people are comfortable with the basic commands. Basic commands, pwd, change directory. Is that kind of people okay with? Anyone willing to say they're not? rm, move more to look at files, to move them, to change them, stuff like that, right? If not, let me know, and we can go through that kind of stuff too, but I obviously don't want to bore people entirely to that. Tab completion. People know tab completion? Get used to tab completion. Especially ROS is really good at completing tabs. And so don't type the full name, hit tab, and we'll just do it for you. So tab completion, a big part. In all those things. So let me not talk too much more about that, because I think we've done that. Let me talk a little bit then. So yes, people are comfortable with file system folders and all that stuff. I mean, I assume that's the same for all of them. Not a big deal. Let me talk briefly about foreground, background processes. This may be, if you have not seen it, a little different. Does anyone know what XIs is? It's this really silly pair of eyes. It's an entirely useless piece of program, but it moves the eyes around. So guess what? I type the command, and the command runs, right? So what is that doing to my keyboard? Not much, right? So that means that I started the program. The program is what I would call now in the foreground. It is blocking my thing. So when normally you type a command, so if you just have your prompt and you type your command, that goes into the foreground. Two things you can now do, and this is what I want to point out. You guys know Control-C? So what's the difference between Control-C and Control-Z? And that's the subtle one.
Well, Control-C like kills your program. Control-Z just moves it, stops it, like
Yes.
suspends it, moves it to the background.
And that's what I just want to make sure that we are all in agreement with. There is a difference between killing it and stopping it. So if I Control-C it, guess what? The eyes go away, as they should. I don't know if you can see, I typed Control-C, which it does, it's that little hat C, right? If I do the same thing, I'm going to up arrow to be lazy, and then Control-Z it, it says stops. Guess what? The eyes are now fixed, they're stopped, right? But it's still hanging around. With the eyes, it's darn obvious, which is why I picked the eyes. When you run a piece of code that doesn't show anything, it just executes, and you accidentally stop it instead of killing it, it means it's hanging around. It could still have files open. It could still be blocking the camera. It could still be doing stuff. And I've seen it happen many times where you think you're shutting down, but in reality, you're only stopping processes. And so then you've got 10 legacy things lying around that can start clogging stuff up and messing you up. So once you have it stopped, what I can do is actually type jobs. If you haven't seen it, you'll get used to taking a look at it. And I'll actually list all the jobs I have. So I can also start at the same time the clock. In this one, I'm going to actually put an ampersand behind it. Have you guys seen that one? If I do command ampersand, I immediately put it into the background. So that way, I now have a clock running. The eyes are still dead. And if I look at jobs, right, the clock is now running, and the ampersand tells me that it was in the background right away. And so what I can do is I can also say BG %1. BG, and there's an equivalent FG for background and foreground. %N is basically the job number. Right? And so I can do a BG %1, and guess what? The eyes should be alive again now. And if I type jobs, they're both running. So you can see what this terminal has done. Okay, I can also do a kill %1. What's that going to do? Make the eyes go away, right? So here, let me put my eyes back because I like my eyes. And guess what? Now it actually said terminated 1, and it's listing the eyes as number 3 because it just keeps that number going, right? So you can't assume it's 1 or 2. You've got to check what it is. You can do a kill %N. So be aware of that. Now jobs is local to that window. If I do, whoops, didn't do that, go away. If I create myself a new terminal, and in this one I say jobs, it lists nothing. Does that make sense? There's a cheating way, which is I say jobs -L for the long format, and it actually gives me this number. So that's the process number. So a job is a process, except that locally in my window it is job number 2 and number 3, and I can refer to it as %1, 2, %3, etc. But globally it's actually a process number which is 21086. So if I cheat, I can go to another window, and as much as that job is not listed, I can actually say kill, what was the number? 2186, and guess what it's going to do? Oh, that was the clock. I thought it was the eyes. Oops. I guess you got to be careful what you kill, right? Just to kind of point out, there's different ways you can do it. There's the process number and the job number, which is the same except the jobs are local. If you're not sure what the numbers are, there is a PS. Here, I'm gonna. PS gives you the process numbers, as does jobs -L. I gotta write my L. The PS will naturally only tell me what's local. I can say it PS-A, and that'll give me all of the ones that I'm using as the user. And guess what? The eyes now show up in here. I can actually do a PS-AX, and it'll tell me everything. And I can even do an AXL, and it'll give me tons of information. And so let me run that again. So you can do an A, an X, and an L. And so for example, I can see that the command itself, PSAXL, right, is process ID 2226. The parent process ID, let me scroll up just a little bit so you can actually see the top of this giant table. The second column, it's a big table. This is everything that's running, which is a huge amount. So user ID is who's running it, root or me. I'm 1000, root is 0. Process ID is the process number, parent process ID. So if you're ever curious how this thing comes about, the command that I typed, PSAXL, right, is 2226. The parent is this one. Guess what? The parent is the shell. Duh. Well, the shell itself has a parent 2010. 2010 is actually the GNOME terminal server, which is actually the window. And if you look at that, you can actually go back in 1353. I don't even know what 1353 is going to be, but that is actually going to be, there it is, the system that started the whole thing up. So you can trace it. So if you actually have a bunch of different things running, right, you can go back and trace them and figure them out. The long of it is, I figured out that my XIs are, what are they, 2187, and then I can kill it. Smaller so you can see killing my eyes. That's a weird sentence to say, isn't it? 2187, and goodbye, there they go. And the last thing I'm going to say in this context, if all else fails, who knows kill -9? You guys ever heard of that one? So, meaning you can do then a kill process number. If what kill does, it doesn't actually kill it. It sends it a signal saying, please go away. It's like quitting an application. If you really crash things, the application's dead and won't even respond to that. So sometimes you say kill and it doesn't go away. And you do a PS and it's still there. And you say kill and it's still there. The catch-all is kill -9 process number. That is the Linux version of force quit. If you have something that's hanging there and it will not go away and it will not die and it will not do anything, kill -9 is going to zap it. And so worst case, do a PS, find it, kill -9, and it's out of there. Right. So all of this, I don't know how interesting it is, but just to kind of make sure that's in the back of your mind, as you run things, you may or may not run into that kind of stuff. Last one I'm going to say in this context, and I'll do the other one, yep, is I did this -AXL, right? It gives you this giant thing. Well, half the time you only care about specific things. Have you guys ever seen grep, I don't know, x? That's a bad one. Here, let me do this. Xi's. I'm going to start the Xi's up. And then I'm going to do a px -AXL. There's tons of stuff here, including what I actually cared about. If you have a hard time finding it, you can pipe it through grep and look for the word i's. And guess what? The result is only these 2 lines. It's the command itself and the original and the actual process. You guys seen that before? So if you put it through grep, grep is a program by itself. What this means is it takes the output of this guy, which is this giant list, and instead of showing it to you, this pipe symbol, this vertical symbol says, take that output and put it into this program. And grep is a program that only shows lines with the word i's, whatever it is in there. So the classic thing that I do when my system is completely bonkers is I'll do a ps-AXL and grep it through -I ROS. -I means it's case insensitive, ignore case, and grep it through ROS. That means I get to see every ROS process that's hanging around. And if there are any, which there shouldn't be because I tried to kill them, then I go in and I force kill them and zap them, right? That's the ultimate kind of cleanup. Make sense? Probably don't need it right off the bat, but just so people are aware, this idea of job numbers and process numbers, and you can go find them and you can go kill them if you need to, because sooner or later we are going to leave things dangling around. I'm out of breath. Was that completely obvious or suddenly new, a little bit different? Last piece, and then I want to talk about ROS after that, is part C, environment variables. So we're running everything out of the shell. The shell will do all the ROS commands for us and everything else. A shell, like any other piece of code, has variables. And it has local variables, and it has global variables. And for some reason, the global variables get called environment variables. And the reason they're important is because when you run the piece of code, those variables get passed to that code. So in Bash, you define variables, and then you say xi's, or something. That piece of code that you then run will inherit those variables. And that is how, in particular ROS, when you start a piece of ROS code, that's how it knows who you are and what's going on. And so there is a command called print env that prints your environment variables. So these are all the variables. What am I doing with i's here? Get rid of these i's. Did I get rid of the i's? No. Kill i's. There. Where are my i's? Kill 2237. Go away. Okay. So if I look at print env, these are all the variables that are defined. And again, there's a gazillion. You'll notice things like Ross distribution is melodic, which is the Ross version that we have. There's tons of stuff in there. A lot of it seems completely useless, but that's what the system uses. You'll find stuff just for the fun of it here. Let me see if I can see something useful. It has like the working directory. It has the home directory that you're in. It has all kinds of stuff like that. So a lot of times what I do is the same thing, is I grep that through -I Ross. So those are all the variables that have to do with Ross. And the only reason I want to show you this is because that's what defines Ross. So I'm slowly switching over to talk about Ross. The ones of interest, Ross master. You guys remember Ross master and Ross core? That actually tells it where to find the Ross master. The root, which tells it where the basic Ross stuff is. So if you're ever in doubt how your system is configured or anything, those are the variables that set this up, that need to be correct. And if they're not correct, that's where things go weird. And so this is how you can find them and take a look at them. And in particular, if you need to change them, I'll go back to here, they're actually in your .bashrc. This is where the Ross ones in particular get set up. And so if things are a little funny, that's usually where it is. So let me, with that, switch to Ross. Is this just completely boring? It's a little bit of kind of the, okay, let's do the legwork and get everything straight, but I want to at least get all these things out and have those commands written down somewhere so that at some point you can kind of go back and use them. That's it, let me erase them. So what's Ross? Yes.
Robot operating system.
Yes. Which is a total lie. It's not an operating system. Linux is the operating system. I don't know why they call it Ross. It sounds really cool. But Ross is the robot operating system. Do you guys that have used it agree that there's two big pieces to it? And that's something that I just want to make sure that people, especially if you're not familiar with it, it's clear. One is there's a file system, and or kind of a workspace compiler, making all the stuff that happens kind of offline. Right? It sets up workspaces, it sets up users, it has environment variables, it does all of that stuff. And then there's a total separate part to it, which is the runtime system. And we'll talk about both. This has nodes, it has messages, and it has everything that you need to run it. And the hard thing is that they do kind of play off of each other. And so you've got to set up the ROS files the right way. And then when you can run it, it runs smoothly. But there is kind of this distinction that one is the file structure that you have to have, and one is the real-time messaging, which are in some sense independent of each other. Briefly, to the file system. Do you guys, well, I shouldn't ask it, I should just say it. Basically, the first step is ROS sets up workspaces. So a workspace is just a certain area of the file system that it's going to play with. So step one, there's workspaces. And, go away, wake up. In particular, that is just a huge chunk of the file system. There are usually two things that you're going to see. One is the main workspace. Oh, man, I can't spell. Which is /opt/ROS/ whichever release it is, which is in this case melodic, right? And so if you look at the root, that's actually where it's looking. If you look at the path, that's where it's looking. There is probably going to be at least a second one, which is the user workspace, which is where probably you're going to put the files that you write. And you could actually have multiple of these. You don't have to have one. But the classic one that people have is under their home directory, they have, and it's usually called Catkin Workspace by default, though you can give it a much better name. Catkin is a make system that Ross uses, so that's what they call it. So if you look at the file structure, I actually have a Catkin workspace in here. Inside of that Catkin workspace is source code, development code, build code, and all the stuff that you need. And so inside of the workspace, right, is all the areas that it uses for source code, building, and all the kind of stuff. Inside the source code are what it calls packages. So there's a gazillion packages you can have in one workspace. Does that make sense? So there's actually, if you look at the command prompt, a ROS CD, which basically takes a package name and goes there. Now I'm going to do something that should fail. So I looked at my Catkin workspace and looked at the source, and there's currently 3 packages in here, which I put in the heavy stuff because we're going to need that, and I put in the real sense because we're going to use it. So for example, one of the package names is called heavy ROS, right? So I go out here and I say ROS CD heavy ROS. No such package. What's going on? So I skipped a step. Yes,
Did you not build it?
I did build it.
Oh, my bad.
You need to source the ROS devel for the Catkin
Exactly.
workspace.
And this is why I brought this up. It is looking at the root and the ROS package path. The ROS package path is pointing to the main workspace, to this guy. But the package, in this case, right, was under this one. So it can't find it. So every time you have a workspace, under the workspace, let me go back to my file. If I go back to the workspace, there's a development, and that is something that it puts in there automatically. And inside of that, there's a setup. Notice there's a setup.z shell, a setup.shell, a setup.bash, a setup, depending on which shell you've used. But we always use bash, so we're always going to run this setup.bash. If I, just for the fun of it, go back to my very first .bashrc, right? This is the one that gets run at runtime. Guess what it does? It sources opt ROS melodic setup. Because it sourced this, the only thing that is in that variable is the opt ROS melodic stuff. So what I need to do is, in addition, go in here and say source my Catkin workspace development setup.bash. And guess what? Now, when I look at my find variables, you'll see that not only is the ROS melodic in here, but also mine is in here, right? In a particular package path. Where's package path? Yeah. Home robot Catkin workspace and ROS melodic workspace. And if I do my ROS CD, it should now go there. And it's gone to my Catkin workspace source heavy ROS. So what happens, I've now done this. What happens if I start a new terminal? And I do my same print env grep-i ROS use. It's not in here, right? In this terminal, it's gone again. Why? Because I only did the setup in here. And so the thing that, and the reason I point this out is because this does happen a bunch of times, is the thing I'd recommend doing is if that is your workspace, guess what? Put it in the general initialization. Put /home robot Catkin workspace /development /setup.bash in here. Save it. Because now, when I open up a new terminal, yet another one, and grep it, it should be properly in here the way I want it, right? So that is, as you start developing, as you make packages, you have a workspace, just so you're aware, what it's really looking at is those environment variables. And so you've got to set them up. And the place to set them up is in the .bashrc because bash is the shell that you use. And that's why I wanted to go through all of that, so that makes sense. If you get another workspace, you got to make sure that it shows up in there as well. Right? Probably you will only have the one, but especially if there's different people on the team, who knows how you end up setting it up. Just keep in mind that is the way that it gets through all of this. Okay. So that means we've got our workspace set up. Once the workspace is set up, you can run stuff. So I want to spend 5 minutes, and then we can also finish it on Friday, about actually running stuff. Because guess what? This is where it gets good. And I spent the entire time to get here, right? Why did I waste all that time? If I talk about the runtime. Do you guys remember there is a master? Who's willing to admit they have not seen a ROS master? Yes. So ROS, besides this file system stuff, and the file system stuff basically means you've got to set up your workspace and it'll find its packages and then it's happy. And the runtime stuff, what ROS really is a message passing system. It lets you run what they call nodes, which are just processes, just different pieces of code. And it allows the nodes to talk to each other. And what it does in runtime, it runs a node 1, which is a self-contained piece of code. In that code is a publisher. And then you can have a node 2, and guess what? It has a subscriber. And so it is a publisher-subscriber method. And what it has its master that sits up top. So the first thing you always do is you run the master. All that the master does, it doesn't do any computation, it just keeps track of the list of nodes. That's its entire job. So then when you start this guy, it basically tells the master, I am willing to publish. It doesn't actually publish anything yet, it just tells it that it's willing to publish. When you start this guy, it tells the master, I want to subscribe. Right? And if the master ends up finding a pair that wants to talk to each other, it tells them, go do it, and then this guy sends it straight across. And the magic that happens behind there is kind of cool because these can be on different machines, they can be in different places on the network, and the master will figure out how to tell them what to do. And it'll figure out whether or not it needs to use UDP pipes or what it needs to do that. So you don't need to worry about any of it. So when we write our code, all we do is we start the master, first thing you always do, and then you start the nodes, and you simply say, I want to publish this, and I want to subscribe to this. And the rest happens then by itself. So, you see if I can do this in the last 1 minute. And I'm sure it's going to fail. Okay, let me clean up a little bit. Exit. How do I get out of here? Go away. Go away! Fine, exit. You go away. What did I open all these things for? Exit, exit, exit. Too much stuff. Exit. So the first thing I would do is I would run ROS core, which is the master. You have now two choices. You could put an ampersand behind it, put it in the background. What I actually tend to do is put it in the foreground so that I can see all of the output. And then I open a new terminal, and I can do something like ROS node list. And by the way, tab completion. If I just hit tab, it tells me all the options. And if I do list, it'll complete it. And it says there's one node currently. ROS out is actually the master node. And so there is a ROS node. There is a ROS topic list, which tells you all the topics. And at the moment, the master. And so ROS out is just a debugging topic that goes to a log file. So pretty much you can ignore it. So right now, there's not much going on. But let me see. 1 minute. Can I hook up a camera? So what I want to do, and if it doesn't, we don't finish it today, we'll do another one. There's going to be basically 3 nodes. One is a camera node that's going to read the camera and produce an image topic. Then there's going to be a face detection node that listens to that image topic and does the face detection and reports the XY. And then there's going to be a third node, which is just a visualization that can take the XY coordinates and look at it. right? And then basically we start those 3 nodes and we've got ourselves a good face detector. And in the future, we'll replace those nodes with something that then drives the heavy. And so in the long run, we'll have like 5, 6 different nodes that talk to each other and kind of set that stuff. Rather than, I think officially we're out of time. So tell you what, I will go through that. That is basically what I'm hoping to get to by Friday. If you feel comfortable, give it a shot. I realize the week has gone short. So let me write the following on the board in the 1 minute. And then I'll go through it on Friday. But basically, there is going to be a ROS core, which is the core. There's going to be a ROS run. You give it first a package name, which in this case is UVC camera. Don't ask me what the UVC stands for. USB virtual camera or something like that. That is a package name. And then the command name is, guess what? Highly inventive UVC camera. So that is the package where you find it, and that is the command. We're going to run ROS run OpenCV apps, because it's OpenCV, and guess what it's going to be? It's going to be face detector. And we're going to ROS run image view, and I think there's an underscore in there, and image view. So these are 3 nodes that live in 3 different packages. But that's going to be our camera, which is going to produce an image topic. That is going to be the detector that takes the topic, and that is going to be the viewer that shows it to us on screen. And with that, we'll have a face detector run. And that's kind of where I wanted to get this week, just get our feet wet. So if you don't mind, give it a shot to try to install Linux. I am going to do my best over the next half hour to see if I can get 8 gigabytes on Piazza. If not, I'm going to figure out how to get it unboxed and what to do. If you'd like to, please, you can download the Ubuntu ISO file, and you can look at the ROS install, and it has a 20-step thing, and you can just do it. So it's the same thing that I ended up doing. But my hope is that basically by Friday, we can type in those commands, and you get a little face tracker. And then I want to come back and be a little bit mechanical next week and talk about motors, because then I want to give the motor the command that comes out of the face tracker, and guess what? You'll have something that locks in on a face and starts moving, right? And then we just need 8 weeks to build some stuff around it, and we'll be done. But that's kind of where I want to go with this. Does that make sense? So this was a little bit of just get all the infrastructure. I just wanted to get those commands up once and have them up, and then we'll get into the ROS and the messages and the good face detection stuff on Friday. And don't worry about Teams too much. Please hand in, if you want to just drop them on the way out or pass it forward or whatever the questionnaire is. If you don't know Teams,